Hello everyone, my name is Wenjun Tang from Tsinghua Berkeley Shenzhen Institute. Today I would like to share this topic for you, sharing distributed energy storages with virtual power plants. This is our background. To fully utilize the advantages of distributed energy storage systems, excellent regulation rate, a battery capacity sharing mechanism is studied here. We try to figure out a win-win solution to consumers with DESS and virtual power plants. Energy storage system can provide a buffer for real-time power balance and has an excellent regulation rate. It plays an important role in improving the renewable energy generation absorption capacity, regulation capacity, power quality, and reliability of power grid. So we would like to benefit from the improvements of energy internet technology. Energy providers and consumers are intelligently interconnected to realize a two-way energy exchange and energy intercommunication sharing networks. In this paper, we developed a mechanism that takes into account the needs of consumers and interacts with virtual power plants through storage capacity sharing. We conclude our contribution of this work is that we consider the customized sharing strategy to benefit the distributed energy storage owners. And also we consider the willingness to refracting trading mechanisms. And finally, we generalize the win-win solution. This is the framework of our mechanism. The interactive mechanism of multi-to-multi consumers and virtual power plants through DESS capacity sharing is the research object of our work. The framework of the interactive mechanism is as shown in this figure. Various types of consumers list part of their DESS capacity to virtual power plants and benefit from this interaction. Virtual power plant obtain the dispatch and control authority of the corresponding capacity shared by the consumers. Thereby, they can increase their flexibility and obtain higher benefits from this kind of sharing. We considered and construct the deterministic interaction models based on the accurate assumption of in the information, fully consider the individual needs of consumers and virtual power plants. The models as demonstrated here, this is the consumer sharing strategy model, and this is the virtual power plants interactive strategy model. The main target of the consumer is we want to generate a supply curve that and then submit it to the capacity sharing trading platform. In other words, the model needs to evaluate the impact on consumers' objective made by sharing their capacity, and it will be influenced by the awareness of consumers to share its characteristics by the extent to which of the overall objective function is affected by the rental capacity. And also, for the virtual power plant, we need to consider its main task, which is to generate two strategy, leasing strategy with consumers and also the bidding strategy in the electricity and regulation markets. The goal is to maximize its overall revenue, partly gain from the energy market and partly gain from the regulation market. Here is the model we modified. And then after we model this strategy, we utilize the realistic data of IS generation, also the load to modify the consumers and virtual power plants from the Pick and Street dataset and also through the Academy license in 2019, and ELIA. This figure estimates the segment with different colors denote the optimized objective value with the change of the sharing capacity. Different colors represent the critical regions. In each region, the objectives are quadratic. The derivative of the quadratic curve represents the willingness of the sharing, as shown here. The sharing price is actually this blue line. And also we can, in the same manner, we can obtain the supply curve in the figure as here. By obtaining the supply and demand curves from consumer and virtual power plants, the interactive trading can be perceived as here. So this point should be the trading point. As the parametric programming generates the solutions during the calculation of the objective functions, the scheduling of all the participants is determined once the sharing price is clear at this point. Take virtual power plant as an example. This figure shows the bidding strategy of virtual power plant, where the least capacity of DESS is 331 kilowatt-hour. The bidding strategy includes the quantities bid for energy and reserve. The corresponding price are also demonstrated here. By employing the sharing capacity, virtual power plant increases its profit by 1.4 times. Meanwhile, all 5 prosumers earn 21.8% benefit from sharing the capacity on average. So the result prove our proposed capacity sharing mechanism can obtain a win-win deal both to prosumers and virtual power plants. Moreover, our employed parametric programming generates the supply and demand curve effectively. So overall, the performance prove the rationality and effectiveness of our method, and the mechanism can make a win-win deal. That's all for my presentation. Thank you.